All right, 5.6, applications and word problems with conic sections. All right, so the first example says a circle with an equation x plus 2 squared plus y minus 5 squared equals 9. It's translated to the right by 6 units, down 8 units, and its radius is doubled. What is the equation of circle in conic form? Well, if we go right 6 units, if we want to take this equation right 6 units, well, looking at our equation, the x's control moving left or right. Well, our center point here would be at -2. So if we move to the right, that means we're going to add 6 to that. And that means this is going to become a positive 4. So that means I would put it into my equation as x minus 4. All right, so we went down 8. So that means this comes from our y values. So that means that center point's at 5. So I'm going to subtract 8, and that would give me -3. So that would give me y plus 3 squared. It said that the radius is double. Well, my current radius is 3 because that's r squared. So the current radius is 3. So if I double that, that gives me 6. So new radius, 6, and so that would become 36 r squared. And so that's all you have to do for that one. Okay. Next, the diagram to the right shows the relative locations of some cities in North Dakota. The x-axis represents Interstate 94. The scale is 1 unit equals 30 miles. While driving west on the highway, Doris listened to a radio station in Minot. She estimates the range of the signal to be 120 miles. How far west of Bismarck will she be able to pick up the signal? First thing I want you to realize is what type of conic section you're actually dealing with in this type of problem. Because we're talking about a radio station projecting a signal, and it says she estimates the range of the signal to be 120 miles, this has to be a circle, with the Minot being our center point. So that's what we're looking at. So if that's the case, -1, +3 is our center point because that's where the radio station is. So we have now it said that the range of the signal is 120 miles. So if I can go 120 miles in either direction from the center point, that's my radius. But remember, 1 unit equals 30 miles, so my radius is actually 4. So 16 would go at the end of my equation. So it wants to know how far west of Bismarck will she be able to pick up the signal. So Bismarck is on the center, the origin, 0, 0. So how far west would be somewhere in this direction? So we want to keep the y value at 0, and we want to know what the x value is. So we're going to look at that. So that gives me x plus 1 squared plus 9 equals 16. So we'll subtract 9. X plus 1 squared equals 16 minus 9 is 7. We'll leave that in radical form for now. If we take the square root, x plus 1 equals plus or minus radical 7. X equals -1 plus or minus radical 7. So looking at this answer choice, you have two answers. You have the positive one and you have the negative one. So since we're talking about how far west of Bismarck, we're going to take the negative answer. So -1 minus radical 7 is going to give me -3.646. Well, if that's the case, I want to multiply that times 30. And so it's 109 miles west. Because remember, 1 unit equals 30 miles. Number 3, the important characteristics of a satellite dish are the diameter d, the depth little d, and the ratio f over d, where f is the distance between the focus and the vertex. A typical dish has the values of capital D equals 60 centimeters, lowercase d equals 6.25, and f over d equals 0.6. Assuming that the focus is at the origin and the parabola opens to the right, write an equation that models a typical satellite dish. First thing we want to know, we know this is a parabola, and we know that f over d is 0.6. And we know that capital D is 60 centimeters. So that means f equals 36. So 36 is the distance from the focus to the vertex. Well, we know that the focus is at the origin, so the focus is at 0, 0. So looking at my diagram, I can see that my focus would be somewhere around here. And so my vertex will be somewhere right here. So that lets me know that my vertex is at negative 36, 0, because it's behind the focus. So the next thing I can find is my focus point. Given that it's a parabola, the equation for my focus would be h plus 1 over 4a k. Well, I know k is 0, so h plus 1 over 4a also equals 0 because that's my focus. And I know h is negative 36. So I'm going to solve this. So 1 over 4a equals 36. So therefore, 1 over 4 times 36 equals a, which equals 1 over 144. So since I have all that information, and this is a sideways parabola, it will be x equals 1 over 144, y squared minus 36 would be my equation. Because I have my vertex, and I have my a value, so I can just plug it into the equation to write my parabola. Alright, a football is kicked from ground level, reaches a maximum height of 25 feet, and hits the ground 100 feet from where it was kicked. Assuming the ball was kicked at the origin, what was the horizontal distance the ball traveled when it's 18.575 feet above the ground when it's heading down to the ground? So we're going to draw a quick diagram. So we know if we kick a ball in the air, this is the pattern that it follows. This is when it starts at the origin. Here's my vertex, and here's when it ends on the ground. It reaches a maximum height of 25 feet, so that's 25, and it hits the ground 100 feet from where it was kicked, so this is 100. So my vertex is 50, 25, because halfway, because parabolas are symmetrical. So what is the horizontal distance the ball traveled when it's 18.75 feet above the ground when it's heading down to the ground? So assuming that this is around 18.75, I'm trying to find this y distance here. I'm sorry, this x distance here. This is my y value. So I want to write the equation for this parabola first. So I have y equals a x minus 50, because I don't know what a is yet, plus 25. All right, so I can find out what a is by plugging in a known value that I do have, which I'm going to plug in 100, 0. Just solve for a. So negative 25 equals a times 2500, divide by 2500, and a equals negative 1 over 100. So now I have y equals negative 1 over 100 and that's my equation of this parabola. Now that I know that, I can set the 18.75 equal to my y. The easiest way to solve this problem would be to plug it into Desmos and find out when it equals, or you can just solve it right out, and the answer is x equals 0.75 feet. Not 0.75 feet. .75 feet, not 0.75. All right, so that gave you an introduction into some of the word problems. The remainder of them I want you to solve on your own, and I will post the answers to the rest of these word problems. I want you to try to work them out, and I will give you time within this video, and I'll give you some hints that you need to know to work them out. This one, notice what you need. You need to find the center point to find the, use the midpoint to find the center point. It's given, the given information that you really need is inside the diagram. This one you need, for number 6, draw a diagram. That is important to solve this problem. And the rest of them I think you can solve on your own.